Welcome to the workshop, Social and Cognitive Interactions for Assistive Robotics, SCIAR. I am Chuang from Cognitive Robotics Lab, University of Manchester. The paper was finished with the cooperation with Professor Helen Hastie and Professor Angelo Congolosi. My paper title is Human-Aware Robot Social Behavior Dynamic for Trustworthy Human-Robot Interaction. Robots with multimodal social cues can be widely applied for natural human-robot interaction. The physical presence of those robots can be used to explore whether or how the robot can relieve the loneliness and social isolation of older adults. Natural and trustworthy interpersonal communication involves multimodal social cues with verbal and nonverbal behaviors, for example, speech, body language, facial expression, and the gaze. Humans always take the attention, intention, and preference of the interactor into consideration to adjust behaviors dynamically. Accordingly, a social robot should factor in human states into the loop to generate and conduct multimodal behaviors in a natural and trustworthy human-robot interaction setting. In this abstract, we explore how we can endow a social robot with dynamical social behaviors with the human in the loop and whether the human-aware robot social behavior dynamics make a difference in trustworthy human-robot interaction. Without human in the loop, we explored talking robot gesture generation. In the work, we build up an audiovisual database with speech audio and 3D gestures. A new temporal GAN framework of the cross-modal generation is proposed for the alignment between the human-like gestures and the speech. Moreover, our model can use one speech audio, with multiple noises, to generate multiple human-like 3D gesture series, one-to-many mapping. The generated gestures given the speech audio are applied to Pepper Robot after 3D pose retargeting processing.
I removed my timing chip and I handed it over to a race official.
Here is one generated sample with the model trained for 1060 epochs. You can see video here. You can see, the gesture frequency maps well with speech prosody or rhythm. Without human in the loop, we explored talking robot face generation. Our facial action synthesizer based on temporal GAN model takes speech audio as input and outputs aligned human 3D facial actions. The robot facial actions are got from human 3D face action during facial action retargeting part. Our speech-to-face action, S2F-GAN, model is based on GAN-GP. The model has a generator and a discriminator. The generator contains two layers of GRU and MLP layer. Firstly, MFCC as audio representation are extracted from the overlapped audio clips. The MFCC feature sequences two layers GRU. The following MLP layer generate the synchronous 3D facial action sequence. The discriminator works to distinguish whether the facial action sequence and speech audio match with each other. The audio clip representations and the facial action sequence are input to two MLP layers. The following concatenation layer fusions the two modal features in each time step, whose output is input to a GRU layer. In the final GRU cell, an MLP layer is followed to classify whether the speech audio matches the 3D facial action sequence.
Oh, Mr. Bennett, how can you tease me so? Oh, Mr. Bennett, how can you tease me so?
Here are the videos you can see. The generated sample and related real sample can be seen here. They are very similar to some degree. Some robots for human-robot interaction are designed with female or male physical appearance. Other robots are endowed with no gender characteristics, namely genderless robots, such as Pepper and Now Robot. A robot with male or female physical appearance should possess the mapped speech gender style during a natural human-robot interaction, which can be learned from humans' male or female speech. In this paper, we make a new trial to synthesis gender-free speeches for physically genderless robots, which is promising in order to improve a more natural human-robot interaction with genderless robots. Our gender style-controlled speech synthesizer takes the speech text and gender style embedding as inputs to generate speech audio. A speech gender encoder network is used to extract the embedding of the speech gender style with female and male speeches as input. Based on the distribution of the female and male gender style embedding, we explore the gender-free speech style embedding space where we sample some gender-free embedding vectors to generate genderless speech audio. This is a preliminary work where we show how the genderless speech audio wave will be synthesized from text. For human-in-the-loop robot behavior dynamic, we will say the research questions are, how can we generate robot social behavior with human-in-the-loop? Does the human-in-the-loop robot behavior dynamic make a difference on human-robot trust? With regards nonverbal behavior, we will explore the interactive robot speech-driven gesture face generation with the human state in the loop. Most of the past works only utilized robot speech to guide the robot gesture or face generation without consideration of the human interactor. However, in real-time human-human interaction, the human cognitive load, emotion, attention, preference, and multimodal behaviors will reflect interactor behavior patterns. Similarly, the human-in-the-loop robot gesture generation model may make a difference for a trustworthy human-robot interaction. This work can be built based on our past speaking robot gesture generation work to explore the effectiveness. With regards verbal behavior, we focus on speech synthesis, specifically gender-style controllable robot speech that takes into consideration both human preference and robot gender characteristics. Firstly, the robot's gender identity based on its physical appearance includes male, female, or non-binary. The robot speech generation should consider appearance-based gender identity for gender-style dynamics. Secondly, the robot's gender identity is very subjective to each human interactor. So the gender-based speech generation also should regard the human preference dynamic. The work will be upgraded from our past genderless robot speech generation work. Thanks for your listening.